Hello, good day everyone. Welcome to my class, Maths with Victor. Today, we want to look at addition and subtraction of sorts. Addition and subtraction of sorts. But the first point I want you to note very clearly from the class today is that before you can add or subtract anything, they must have the same form. They must look alike. That's what we call similar terms or like terms. For instance, if I have 10 cows, it is practically impossible to remove 5 goats from 10 cows. Why? Because goats and cows are quite different. Similarly, if I have 10 cows, I have 5 goats, I cannot add them together to simplify into one. Because when I do that and I have 15, then it becomes 15 what? 15 goats? Of course not. There are cows there. 15 cows? Of course not. There are goats there. 15 goat cow or cow goat. It doesn't make sense. So things are added or subtracted together because they are similar. Now, in the same way with sorts, before we can add or subtract sorts together, there must be similar sorts. How do we know similar sorts? Of course, there are two ways sorts can be written, either in their single form or in their basic form. The forms we have here are single form of sorts. Why? Because in each of them, we have a number inside a square root, a single number inside a square root, a single number inside a square root. They are called the single form of sorts. So what we do is that we convert these sorts from their single form to their basic form. How do we do that? So I start. Look at the first number very clearly. We have 72. So what we do is to find two numbers that will multiply themselves to give you 72. But one of those two numbers must be a perfect square. This condition must be met. I repeat, one of the two numbers must be a perfect square. What is a perfect square? A perfect square is a number whose square root is a whole number. So I proceed. Looking at 72, I think of two numbers that I multiply to give 72, and those numbers will be 36 and 2, because 36 times 2 gives you 72. So instead of 72, I will have square root of 36 times 2. I have not changed anything because these two numbers multiply themselves will also give you what? 72. And then plus, instead of 50, I will have 25 times 2. Remember, we are looking at two numbers that will multiply to give this number. Someone may want to ask, why not 10 and 5? Of course, 10 times 5 gives you 50. That is correct. But the condition of perfect square was not met if you use 10 and 5, because 10 is not a perfect square. 5 is not a perfect square. The square root of 10 is not a whole number. The square root of 5 is also not a whole number. So we can't use 10 and 5. Similarly, 18 becomes 9 times 2. The same reason why I cannot use 10 and 5 here is the same reason why I cannot use 6 and 3 here, because neither 6 nor 3 is a perfect square. So we can proceed now. In the rules of sorts, remember this square root is for both 36 and 2. So we can split them together. So instead of square root of 36 times 2, I have square root of 36 times square root of 2. The same way here, plus square root of 25 times square root of 2. I'm splitting them out into different square roots. Then minus square root of 9 times square root of 2. So we can easily simplify the square root of 36, the square root of 25, and the square root of 9 because they are perfect squares. So square root of 36 is 6. So this becomes 6 root 2 plus 5 root 2 minus square root of 9 is 3 root 2. So I want you to look at these sorts clearly now. You can see that they ended with root 2, root 2, root 2. That's why they are called similar sorts. So we can add them, we can subtract them because they ended with the same roots or with the same sorts. So how do I add now? Very important. You add the numbers outside the square root. The numbers that are multiplying the sort, that's what you add. So 6 plus 5 gives me 11. That means this will simplify to 11 root 2. I still have this minus 3 root 2. Then I'm going to subtract 3 from 11. When I do that, I have 8 root 2 as my final answer. As simple as that. As simple as that. I want us to look at another question very clearly. This is NECO question this year. Objective question number 5. very quickly. I will do that as fast as possible because of time. We have 2 root 18 minus 4 root 32 plus 3 root 50. The same thing we are talking about, addition and subtraction of surds. So we break them down to their basic form. This is 2 root 18 is 9 times 2, minus 4 root 32 is 16 times 2, 16 times 2. Then plus 3 root 50 is 25 times 2. And then we continue. The square root here is for 9 and 2. We can split them out. So we have 2 root 9 times root 2 minus 4 root 16 times root 2 plus 3. I split them out also, root 25 times root 2. When I proceed further, we can find the square root of 9, square root of 16, square root of 25 because they are all perfect squares. So this is 2 times square root of 9 is 3 times root 2 minus 4 times square root of 16 is 4 times root 2 plus 3 times this is 5 times root 2. 2 times 3 is 6. So we have 6 root 2 minus 4 times 4, 16. So I have 16 root 2, then plus 3 times 5, 15. 15 root 2. Just like I said before, they are similar sorts because they ended with root 2, root 2, root 2. So we add the numbers outside and subtract the numbers outside as the case may be. So I have 6 minus 16. 6 minus 16 is minus 10. Minus 10 root 2 plus 15 root 2. Minus 10 plus 5 is 5. Sorry, minus 10 plus 15, apologies, is 5. So we have 5 root 2 answer. And that is option number C. Very simple. So I'll give you what to do. Quickly do that and leave your answers as a comment. Let's see how many of you got that. Kindly like, follow my page, share it to your friends, especially high school students, and subscribe to my YouTube channel. So I will leave you with this quickly. Remember, if I'm too fast, you can always pause the video. So you solve this square root of 75 plus square root of 12 minus square root of 27. Simplify this and leave your answer as a comment. Thank you. God bless you.